Hey,
Howdy.
what's happening? How are you doing?
Pretty decent. How about yourself?
Pretty well. I just misplaced some wires, so I don't have my normal microphone. But happy Monday to you. Happy Monday to everybody out there. We decided to do the stream a little bit early because it met our time frame better. So Marcus, you're going to tell us about dairy farming, dairy processing.
Yeah. I have worked on several different dairy farms, and I have worked in several different dairy processing plants. It is a pretty big thing in Wisconsin, I guess. It's a pretty common entity in the area for business. But yeah, so the first step is first. You basically get milk from a farm brought in, and that would be the first picture I showed you. Hold on, I'm on Telegram too.
Oopsie, going into stuff. I don't know what image that you're talking about. Where does it come in from the farm? Here?
Yeah. Yeah. Oh, sorry. No. I'm trying to figure out how to play on the computer here.
Have
that
I crippled you?
There we go. All right. I'm all paying attention now. I just put it in Telegram.
Ah.
So there's the intake.
Hold on a second. I got to get my brain moving.
Yeah, I just woke up too, so don't worry. I'm still a little groggy. Try and drink a liter of water, and then I might feel a little bit better.
So yeah, I have that image here. Back sharing again. Here we are. So the trucks roll in, right inside
Yep.
this space.
Roll in, and they get hooked up to a hose and a pump, and it sends it back to a milk silo or a whey silo. That's the next image I just sent you. That's the milk alley there. So it gets sent back through the basically the large pipes, and
Is
they
that
get hooked up
this?
to this.
Is that this one?
Yep, you can see them there. The large pipes there at the top left. Those are kind of where they go to, and then it gets sent down to.
Wait, I'm fascinated with this truck stuff. So the truck comes in.
Yep, rolls in right where your cursor's at.
Uh-huh. What gets spilt on the floor? The extra milk?
There's a little bit of milk that runs out of the hose when you take it off,
Okay.
but other than that, milk or whey. But other
So
than
somebody
that,
gets on top of the truck?
yep, and you take a sample, and those samples we test for antibiotics, lactobacillus test, because you can't have any antibiotics in there. I think it's like 1 in a billion or something like that is what they test for now. So it's not very common that we get an antibiotic positive test. To be honest with you, I think I've only seen one. But that's a big deal, because you can't even feed the milk to the animals at that point in time. You have to basically you have to dump it. It has to be dumped into a digester.
Whoa. So this little safety hazard shower off to the left, what's that used for?
There's chemicals. There's chemicals and chemical totes. You can see barrels on the far right hand side. But there's chemicals over there, and by law, you have to have one of those in every area. You have to have one of those safety showers in every area. And the water is cold, I promise. I've had to use it before.
Awesome.
Yeah, it's really cold water, and strip down into your underwear in the intake, and you're standing underneath a cold shower.
So is this like a straw suck that happens? Like when you put the tubes, I guess, in the tank?
They don't go in the tank, they go on the back side of the tank. There's a valve that is on the back side of the tank on the bottom. And you basically hook a hose up to it. And if you zoom, or if you look, you can see there are hoses right where your cursor is at. That hose, those hoses, those basically get hooked up to the back of the trucks. And if you move your cursor to the right just a hair, that's where the motors are at, like right to the left just a touch. Those are valves. Those tell it where to go. So the milk comes in through that white motor, and it goes up into that valve cluster. And there's valves in there that say open and close wherever you want it to go.
Sweet.
Yeah, there's a lot of pipes. It's intimidating at first, but it's not too bad once you get an idea of it. So this is where it ends up. It ends up. These are silos on the right and the left hand side. That's where it ends up. And then from there, it goes to a pasteurizer. I'm going to tag that one.
Is that with the keyboard? So it's not beneficial to me for you to tag them like that. I'm wondering if I already have them in order.
I put them in order.
Well, I didn't change the file name, and I think that it was saved based on order. Well, so yeah. Come on. This is the one. I thought I was sharing it with you. This is the one.
Yep. So that's the milk area, and those big pipes on the left-hand side, right next to that red cap. That's where milk comes in, and there are 4 milk silos. That's another basically a transfer plate. So you move those lines to wherever you want the milk to go, or if you're going to wash the silos, because they all have to be washed, after you use them and stuff like that. All the lines have to be washed.
So you're saying this cap on the left is where everything comes in?
Yep, that line right there where you're at.
Okay.
Comes in at about 300 gallons a minute, plus or minus a little bit.
Wow.
Yeah. And then if you move your cursor to the right, that's the motor that sends it, that pulls it out of the silo, and then it goes up. And right above where your cursor's at is that plate where those lines basically dictate where it's going to go. And that'll take it down to the cheese area, which the next photo should be. That'll take it to a milk pasteurizer. I have a picture. That's our pasteurizer. It pasteurizes whey, but it's the same thing. And if you scroll through after the milk pasteurizer, that is the vat. That's a finishing vat. So this is a vat where the culture and salt and calcium is added. So after the milk is pasteurized, it gets added with UF milk, which is about double, because I think milk is about 8% protein and about 4 or 5% fat. And then it basically pulls the lactose and water out of it. So it more or less doubles it. So it goes up to about 15% protein and about 12% fat. And then the next image will be a finishing vat where the rennet is added. So this is where it's going to make it into curd. It's going to, turn the milk into curd. And there are knives in there that will basically spin and cut the curd, and it will get pumped out. And then I should have another one. And then the next image after that will be, that's the milk UF, same thing as ours. Go one more. All right, and then after the curd is pumped out and the whey is pulled off of it, you have a more or less, it presses it down and then it puts it into the barrel. It basically grinds the cheese up and it goes into the barrel, and it's still hot, so it will compress a little bit more, and there's still a little bit of whey left over, and then it'll get pressed one more time to make sure it all fits in there, because those barrels weigh about 480 pounds, plus or minus a little bit.
God, they look big.
They are big. I could fit inside of one pretty easily. Mm-hmm. They're not quite, they're up to my waist in height, but they're about 480 pounds, and we get about 12 to 16 barrels per vat. So, and then after that gets pressed out, the next image you'll have is it gets basically tagged and wrapped up onto a pallet and then put into the cold storage for shipment, awaiting shipment.
Yeah, I see I see those huge AC units up there.
Yeah, there's a number of them. That's the newer storage facility we just had built. And this is an area where the whey is separated. So in the back, like in the back middle, there's something that right there. It looks kind of like a cone. That's a centrifugal separator. It basically pulls all the cream off of the whey. And then on the left-hand side, behind all the pipes, there is a cream tank and it basically separates it, because the whey can't have any cream in it because it'll mess up your membranes. They don't like fat. So, or the RO membranes don't like fat. Can't run any fat through it. So that sends whey up to us up top, and back to one of those silos again, which is going to be just waiting for us. And then I got one more picture of a pasteurizer. It's our oh, that's skipped ahead a ways. I thought I had more images in there.
I probably saved them in the wrong order.
Oh,
so these guys?
Yep, keep going.
These guys?
Yep, one. Yeah, so up right there. So from the silo, that's our pasteurizer, and that's a pretty decent sized pasteurizer. That's bigger than one I've ever seen. It's about 6 feet tall and about 14 feet long or so. We can do roughly 195 gallons a minute maximum. So
wow.
Yeah, that's what we can do roughly. We can pull through about 2.5 million pounds of whey a day is what we can run maximum. But yeah, this is that's meh. For somebody who knows dairy, it'll be interesting to them.
So this right here, it's connected to a series, or it's a one-way stream, right? It's not going into another tank and then coming back again, circulating, right?
Yeah. So on the bottom side where you're at, move your cursor straight down. Keep going right there. Up a little bit higher. Those lines right up in there, they send it into the pasteurizer, and it goes through, and there's hot water on one side of the plate, and there's whey raw product on the other. So there's different sections in that pasteurizer. That one you're on right now is a heat exchanger. So that's the heat plate where the hot water is at. And if you move to the left, that one right there, that bigger one, is the regen section. So it's basically using the hot product that's pasteurized to warm up the cold product. And then if you move to the left a little bit more, there are little sections there on that plate that it just cools it down the rest of the way down to about 60 degrees or so, 55. It's all about efficiency. They're super efficient. Everything is as efficient as possible. And if you go through to the next image, I'll show you the UF. Oops. That's the UF right there, and all of those stages, those vessels, cigar-looking things, are getting product sent to them that's already pasteurized and ready to go. So it's each one of those stages is connected in the series, so they go from left to right. But each one of those stages are connected, so they all more or less take a little bit out every time. Each stage 1, 2, 3, 4, 5, 6, and 7. And by the time you get to stage 7, it's pretty well done. It's already pulled all of the protein off of it and pulled all of the lactose out of the whey.
Okay. that was really technical.
Think of it like imagine I'm trying to think of a way to describe a membrane. It's like a wrapped up piece of like parchment paper, or not parchment, like canvas almost. And it's basically product comes in outside of the membrane, and through pressure, it pushes the water basically through it, carrying either the protein or the lactose. So it'll carry the lactose because lactose is smaller than protein. So that'll carry it through, and it basically separates it through pressure. That's how membranes work. Same thing with like an RO system. Like for water, they can do that with seawater, where they can separate the salt from the water. we're doing the same thing here, but just with whey.
Sweet. And are these carts movable? No.
No, they're mounted to the floor.
And then
They are mounted to the floor.
do these things ever come out?
Not unless you have to. They're mounted in there, and the caps come off. And see where those hoses are? Those little white hoses. Yeah. Those caps come off, and you can push the cigar. They look like a cigar. They're tubular. You know, they're a membrane, and you can push them out the back side or front side, whichever side you want to do it, to change them, because they do have to be changed periodically, and it's nutty how expensive that stuff is. You know, to give you an idea, one of those one of those series of vessels there is about 20 grand worth of membranes, to give you a rough idea.
Nice.
It's insane how expensive that stuff is, but this is all about efficiency, because before, dairy plants, they used to, give way to the farmers. But with the rise of lactose and protein demand, it has become basically obligatory to harvest all of the resources off of it. Because if you have a 40,000 pound vat, you're going to get 30,000 pounds of whey out of it, and 10 to 12,000 pounds of cheese out of it. So all of that other product that has to be gotten rid of, well, we just process it, and we make, it looks like chocolate milk, like light colored chocolate milk. It doesn't taste like chocolate milk, but that's what it looks like. That's about it's about 25% protein. So it goes from roughly 8 to 10% protein to 25% protein. That's what the UF does. And then if you scroll through,
does anybody have questions? Put them in the chat. This is the same thing, right?
Yep, those are that yellow looking stuff is the permeate. So that's the stuff that's coming off of that. That's basically the lactose, the sugar water that's coming off. And then the next one, that's what?
Where does it get stored?
The protein will get, or the protein will get stored right behind the UF there to the right hand side of the screen. There's a couple left. That tank there behind. Move your that tank right in that area. Yep, there's 3 of those tanks, and that'll get stored there until we either process it or ship it. And then the permeate will go to the RO, which I don't think I had any pictures in that. We were kind of working on it, and I didn't want to have anybody else in the pictures. So, but if you move your,
HOA had a question. Do I understand that we make cheese here? Yeah, earlier we were boxing cheese and getting it ready for send out. This is all cheese, right?
Yep, that's all cheese.
And then where does it go?
Well, that's the other deal too. We are shipping cheese kind of all over the northern Midwest because there's no cold storage facilities. We do have a contract with Kraft, like your Kraft macaroni and cheese. Like that's where a lot of that cheese comes from. It's from us.
That's the cheese.
Yep, this is bulk production cheddar is what they call it. It's not colored; it's white. It's cheddar cheese. I mean, it's nothing too crazy about it, but it's not aged or anything like that. It's for like Doritos and stuff like that, or Cheetos. That type of cheese stuff they use on that. A lot of that is used we produce that style of cheese in that respect.
I had that same question, so thanks for answering it.
And then if you keep scrolling, so there's our WPC tanks. That's where that stuff from the UF, the permeate or the protein comes off. It gets stored in those tanks. Those are the same tanks those are the same ones. Yep.
Sweet.
Just a different view.
Sweet.
And there's pipes running all over the place. So don't try and follow them. You can't follow them in a picture. You got to be standing in there. It took me like probably 3 months to try and figure out where everything went. Now I can tell you without even looking at it.
I feel sorry for the guy who drew this thing up before it was created.
You should see the engineering documents. It's pretty ridiculous. Those are RO stages. They look very similar. They're just a different membrane, so they have a little smaller opening than the UF membranes. I don't know the actual size of the opening, but that one runs at a lot higher pressure, like 550 psi. So that's going to pull the sugar off of the water. It's going to separate the sugar and the water, and then that will get stored. The permeate, the sugar water, will get stored in a silo to get processed by our evaporator. Yep, and those are also about $20,000 per stage. So
I was wondering where it was connected, and it's down here at the bottom.
And there's another one on the other side. So basically, the membranes have they have a hole in the middle, and the pressure pushes the water through, and it comes out through a tube from the middle, and everything else that's left over is pumped out through that.
Okay.
It's difficult to.
Drainer. This is the drainer.
Excuse me. That's the inlet, and the other one. It looks like the same thing on the other side, but that is the entry, and then the drainer is on the other side. I don't have a picture of it. They look pretty similar. The UF, the one that you've seen on the front earlier picture, you could see it where that white hose was connected, and there's a little entry point or exit point right there. So it's
what is this interesting spark plug situation?
That is a pressure transmitter. So each one of the vessels has pressure, basically a pressure reading on it. And there, like I said, that one's about 550 psi. So fairly high pressure. The UF runs at about between 40 and 100 psi. And
is that stainless steel?
Yep, this is all stainless. The only thing that's not stainless is the little the display, and the wires are not stainless.
Oh yeah. Okay.
And then that will run to the water and the lactose will get separated there. The water will run to our polisher, which is going to pull off the rest of, if there's any minerals or anything like that left in the water.
That's
because there's a lot of that is a blower motor for our evaporator. I will get to that here in 1 minute.
Where's the polisher?
The polisher looks the same thing as that. It doesn't look any different, but if you zoom in, you can't really see it. I wasn't able to get a good picture of it, but it looks like water in those little tubes. Those little, you see how it's yellow on the left hand side. The polisher's on the right hand side. It looks a lot lighter colored. That's a polisher. So that pulls off all the minerals, and if there's any lactose left in there, that'll pull that off. And we will run approximately 120 gallons a minute of, it's not potable, but cleaned water to our water silos that will heat it up so that we can use it for washing and whatnot like that. It's because if you think, if you get 2 million pounds of milk a day, 8% of that is going to be water. And you might as well use the water versus just, trying to pump it out of the ground.
It's very interesting.
Yeah, it's like I said, everything is super efficient. They literally recover every usable product out of it. Because if you're obligated to do it that way. Because somebody else is going to be, a little bit more efficient and be able to charge a little bit better price.
So you couldn't just drop it on the ground outside?
No. The Wisconsin's kind of strict on that stuff about sending like wastewater. You can't do that. They will have your, they'll get you if you're doing that. They don't let you just dump stuff on the ground. We did build a wastewater facility at this plant as well, and I don't have any pictures of that because it's in a different building, but that one does about 200. It does about 0.2 million gallons a day. That's how you measure it, is a million gallons a day. So I don't know, 200,000 gallons a day, 250,000 a day.
I don't even know what size that would be. So what do you do with the water now?
The water will get stored in a silo and it will get heated up and used for washing. Like you're washing all those membranes and stuff like that. They have to be washed, on a daily basis to meet standards through the FDA. And that it just saves a lot of energy, because if you can heat the water up, if you've got 100,000 gallons of water that you can heat up to 100 degrees, to get it up to 105, it doesn't take that much. Whereas regular tap water is 60-ish degrees, so you've got to heat it up a lot less. That's what we do with the water. Now, the only negative thing about that water is it doesn't really have any minerals in it. It's not distilled, but it doesn't have any minerals in it. So its pH is fairly low, like around 5 instead of 7.
Mm-hmm.
But that's how we recover all the water. And it, like I said, it's an efficiency aspect. You would have to pay to have all that water gotten rid of. And if you don't, want to use it, there's, it's just going to cost you money.
Yeah.
And then so from the permeate side, so you can keep going. So that, if you go back,
where do you want to be?
Back. All right.
Mm-hmm.
So that blower, that's a 200 amp 3-phase motor. I think it runs 640 volts. It's a big motor, but it more or less will create a vacuum. If you go to the next picture, there's a it's kind of cluttered, but if you go to the left, down, right, up a little bit more, right in there, that is a big fan in there. It's a fan that's about 7 or 8 feet across. I don't know exactly how big it is, but that will create a vacuum so that when the permeate, which comes in at about 20% or 21% sugar, it will evaporate it'll evaporate about 40% of the water off, and it'll get it up to approximately 50% sugar. So the reason they use that big fan is because that thing that's connected to it is to more or less create a vacuum, because water will boil at 180 degrees. Because if you heat the lactose up to more than about 180 degrees, 190, it'll burn it and it'll turn it like brown. So you've got to do it that way. If you go to the next picture, this is where the permeate comes in on top, and this is about, I don't remember if it's 60 or 80 feet tall. It's about 80 feet tall, I believe. So there's another 3 sets of steps up there,
And
but that's connected to that.
This is the bottom of that thing.
Yep, that's the bottom of the evaporator.
Wow.
It's absolutely insane. It is really crazy, but we actually...
So, over here, where is it that the stuff comes in to then be centripetal or vaporized?
It's
vapor up there.
It actually, so if you go to the next picture, it comes in on the top of that. It comes in over top of it, and that's
over
hot.
Here.
It's like that's the vacuum. So it comes in over top of that, and there's little tubes that go down through it, and it runs through those tubes. And basically, the water will evaporate out the top because it's in a vacuum, and it's about 180 degrees. And the solids will drop back down. In the first picture you just showed, they'll drop back down to that fan motor down to the bottom there. So to the right, where the bottom of that, there it is, right there, that bottom area right there.
Right here.
Yep. It'll drop back down through there, and it'll get pumped to a holding tank where if you can go to the next picture, one more. Okay, so this is the dryer. So from that holding tank, it's going to get cooled down to about 60 degrees. And then from the dryer, or from the evaporator, it's going to go to the dryer, which that is it's a big plate in there, and it's got knives that move up and down, and they go against the plate. So the evaporated perm at about 51% solids will basically get sprayed onto that plate, and it's hot and it's in a vacuum, but the vacuum is a lot lower, and it will basically scrape that off, and you'll get basically dust. If you look in the bottom of the screen, there's a see-through to the right there, that little thing, you can see the powder dropping through, and that will get sent to another holding silo. I think if you go ahead, so there's one of the holding silos. It's all powder, and it's all done by air. They move the powder with air. So it's really important to make sure that you have, if it's got more than, I think it's 3%, more than 3% moisture, it'll clump up. And I promise you, trying to clean those pipes out of basically concreted lactose powder is absolutely no fun.
Yeah. Wow.
I promise. I've had to do it before.
So it's just engineered the same way that fluid is?
Yep. It uses air. So yeah, the same, okay. That powder will flow, and it uses air, and that's how I didn't, when they were building it, I was like, there's no way, but apparently that's the way it works.
All right.
Seriously, I laugh about it, but the powder is really, really fluffy. It's really, really light.
Yeah, I can tell. It's the way that it sticks to this.
Yeah, it makes a mess. It's terrible. You can never, and that's a thing in there. You can't really be using water. You can't really, this is a completely dry area. It's like 10% humidity in there, because you cannot, the powder will absorb moisture as fast as it can. And if you do, you'll have a little rock, and that's no good.
Yeah.
And then keep going, one more. Those are blowers to create the vacuum. Or sorry, those are blowers to push the powder. My apologies.
So all this powder that's around, it probably escaped these areas of mesh, right?
Yeah, they're like a vinyl. But yeah, I mean, there's no way you're gonna, keep it from, you can see it on the floor and stuff like that. It's not, none of it makes it to the food, but it's all pressurized. So all this stuff that gets out, nothing gets back in.
And this is a sugar that was taken from the water, or what is this?
Lactose. Yeah, that's lactose. Yep, that's milk sugar.
Sweet.
Yeah. So that's like what people are lactose intolerant. They can't have that. But it's commonly used in like medications as a filler. Candy bars, protein powders, stuff like that. They use it as a filler because you can have a little bit of it, but when it gets over a certain percentage, some people react to it. Actually, I think a lot of the world reacts to it.
So why do they use it as a filler? Is there some like special write-off where they're like, oh, well, we added so much of milk?
No, the reason they use it as a filler is because it's very inexpensive. It's cheap, relatively cheap, and it won't. It's not going to cause any side effects other than versus trying to use another filler in a pill or in a protein powder. It basically bulks it up without causing any real negative side effects.
So how many different products do you have out of milk? Milk comes to you. How many different products do you sell out the back door when you take in milk out of the front door or whatever?
So we have cheese, we have lactose, and we have protein powder. So those three things that we sell, and we can't sell water or else we would. But yeah, so those are the three products that we produce. And unfortunately, our protein dryer is not finished, or else I would have included that. It operates very similarly to the lactose dryer, but that because there's different grades of protein. There's 80 and then there's 90. If you ever go to the health food store and you'll see like whey protein isolate, that's a 90% protein that they use. And that is, it has less lactose in it, and it has, there are specific amino acids that it's higher in as well. I don't know those right off the top of my head, but the price disparity or discrepancy between the two is like 30 or 40%. And if you go one more, I think I'll go. Okay, so see that funnel up top?
Yes.
That funnel right there, that's one of those things you've seen on the last picture. That's one of those tanks, and that funnel runs through. And the next picture that'll have where the bags are set up. Now this is pretty much all automated. So it's you push a button, you put the bags in there, and you make sure that everything is done. But pretty much everything is automated. So it fills the bag, it seals the bag, and it runs a strap, or it sews the top of the bag shut. I don't know if you've ever seen a feed bag or whatnot.
Does it do one at a time?
Yes. Yep. It'll do one at a time. It can fill it's 25 kilograms, because we do most of our sales overseas, so they want kilograms. I think that's like 55 pounds, but it can fill one in about 30 seconds.
And then what is this dump area over here?
That is for runoff. So if there's always a little bit that's left over, and lactose is pretty abrasive, so you don't want to get it into the machinery parts. So there's a little bit that's left over from when the slide at the top of that or at the bottom of that funnel opens and closes. Yeah, there's a slide right in there. When there's a little bit left over, it'll blow it off to the side, and it just blows it into a barrel.
Awesome. So whenever this bags it, does it, sorry for this tedious question, does it set the bag right here and a worker grabs it, or this is just the loading and then it takes it this way?
Yep. There's a conveyor behind that little screen there that pulls it over to the right. And in that time frame, it'll send it to a pallet where a worker will have to grab it and more or less put it onto a pallet. I didn't include our bags in the warehouse just because it's got the name of the company on it and stuff like that, and I don't really, I don't want to dox myself too bad.
Good deal. Yeah.
So I did make sure that everything was, not a picture of anything that was important or anything that was related to me. But
I thank you for showing us so much, explaining so much. Do we have more images to go through?
I don't think so. I think that was it.
Yeah. Awesome.
I'm pretty sure. Let me look here. I'll just look just to make sure. And yes, that is it. That was a lot of the images I had taken. It's an interesting place to work. But to give you an idea, we were going to talk about cost, and and how astronomical the costs are for stuff. Like I told you about the membranes and whatnot. Those are $20,000 a stage, and not to mention all the engineering and all of the other stuff that goes into this. But I mean, the overall cost that you're, looking at, even for a smaller factory, is going to be close to $10 to $20 million to do something like this. So wow. It's not, it's crazy how the industry has changed over the last 30 years or so. Before we had smaller cheese factories that produced, product, and you sold your product mostly locally. Most of the product was sold within 50 miles, whereas like the newer style factories are selling product within the country, the world, I guess. A lot of our, like I said, a lot of our lactose goes overseas.
So these constructions, are they steel buildings, or some of them like majority concrete because all the floors have to be washed clean?
Yeah, it's the most of the construction is concrete. Pretty much all of it is concrete. The only thing that's really steel in there is all your stainless steel, because everything is stainless steel as well. They don't use any other types of steel, because everything's got to be cleaned, and a lot of this stuff deals with some pretty heavy chemicals, some pretty corrosive and aggressive chemicals. So that's why they use stainless steel, because that's a sanitary product, I guess, or you can clean it. I think I would really like to see this not progress in the respect of the whole national or international sales type, just because of what it takes to do that. It's incredibly intensive in form of energy and in form of labor. This has been going for 10 years. 8 years they've been building this place, and they're still not done.
Wow.
Hopefully by 2026 it'll be done. So
now, was that because of their economical plan that they didn't build it all at once, or does it?
Yeah.
What made them? Okay.
Pretty much.
The plan the whole time. Same plan.
Yeah.
Takes a while. Okay.
Yeah, because I don't know how many yards of concrete they have in that facility, but the facility itself is just under 3 million square feet.
Wow.
It's a fairly large facility, but they're, like I said, they're still building, and they are going to continue to build for the next 3 to 4 years at least. Which, if that's what you like to do, I just would hate the risk involved with it, because it was. I seen the numbers, and this is not the final number, but it'll be close to $1 billion by the time it's all said and done. The amount of investment that it took.
That's
Which,
incredible, because you just gave me a different number.
by the time it's done, because we've still got another 4 years of building, because it's 600 and I think it's 650, I think is what what the current investment is. And it'll be close to $1 billion by the time it's done.
So what was the 15 to 20 million that you gave me earlier?
That would be monthly revenue, I would.
Okay.
But the 15 to 20 million is a monthly revenue, not the total profit, but revenue.
Do y'all run during the evenings?
Yep, 24/7, 365 days a year. That is not shut down in the last, since 2015.
What's the cleaning schedule?
Every 24 hours, a lot of your pasteurizer and your UF, per the state requirements, you have to clean. So every 24 hours, it has to go through a cleaning cycle.
Do y'all have special lights that are like the killing type waves?
We do have UV lights on our polisher, so that basically to keep any bacteria, at bay, because we're going to use that water for cleaning. That does have a UV light that it basically the water passes through it, and it kills everything in the water.
What's the offices like in that building? Is it like, do you have a locker, or what? Are
Yep.
you able to take a shower before and after duty? Do you have a full suit on? Did you have to wear a mask? Do you still have to wear a mask?
They tried to do the masks for a while, but kind of didn't really fly over very well with everybody. So no, we don't have to wear a mask. Yeah, they tried to do it, and threaten people like, well, you're going to get fired if you don't. Well, then fire me, I guess. And they never really fired anybody. It was more or less a threat is all it was. And I don't agree with the whole mask idea. If you want to wear it, perfectly willing, go ahead. I have nothing against that, but I don't want to be told I have to. And that's kind of the way everybody feels around there as well. We don't. It's a smaller community, so it's not. How do I put it? I don't want to use the term. It's a lot more conservative than it is liberal, I guess. Put it to you that way.
So, what? Before I forget it, was it like a friend of a friend's connection, a family friend? Like, how did you hear about this job opportunity? Take it, learn from it. Have these people been mentors to you?
I was referred by a friend to this place because I got in shortly after they started, and they were looking for help, and I applied, and I got to learn so much that my boss is a really awesome guy. He's done business in, I don't remember, like 80 different countries or something like that over the last 40 years. And he has been a wonderful mentor to me, asking him crazy questions about, what would it take to start a business overseas and stuff like that. And he has been a great mentor in that respect, to where he can, because he has experience doing that. He has went through and helped anybody who wants help. He'll more than gladly help you. He's a wealth of information, and he's in his 70s, so he's not going to be around forever. So I'm trying to get all the information out of him I can.
Lovely.
But yeah, he's a really great guy. The guy's work ethic is absolutely insane. I don't, for being that old, he could have retired long ago and been just fine. But he says it. He said it to me the other day that he's gonna die in that place, or he's gonna die before he retires. So that's just the work ethic he has.
I know the type.
Where
Good for him.
Hey man, you don't have to work anymore. There's no real reason, but I think he finds enjoyment out of this, and I don't understand how. The amount of stress that he's got to be under. I would be absolutely astonished at how you enjoy that. But to each their own. Oh, and one quote from him that I'll never forget is, if you're gonna start a business, don't use your money.
Ooh.
That was his quote, and he was specifically talking about overseas business.
Okay. Can you give us also maybe a story?
He was working in Libya, and he was in the 90s. He was working over there, and they were putting in water filtration facilities over there about every 25 miles from Egypt, because this is when Egypt and Libya were kind of fighting during Muammar Gaddafi. He was in leadership at that point in time, and he more or less learned that from one of the representatives over there that basically said, not to use his money to start these facilities. They were basically government grants given to him by the Libyan government. So he said he got to get interrogated for 3 days by the Gaddafi crew, is the way he put it.
That's special.
He was an American, so they were kind of,
easy with him.
Yeah, he wasn't. He said it wasn't bad. It was just a hotel with bars on the windows, is all he said it was. But they were just investigating him, making sure, But yeah, he's worked all over the world. He's worked quite a bit in Africa. He's worked a lot in Southeast Asia. Worked in Japan, But yeah, he is such a wealth of information that I wanted to retire from there, but unfortunately the hex price didn't really give me the opportunity yet, but it will eventually.
Oh, that's hilarious. An ongoing working situation. I wanted to retire from there, but hadn't gotten to that point yet.
No, and to be honest with you, I don't think I will. I don't know. I've gained more respect for, the company and my boss over the last year or so. He's really, really taken, because he'll take time out of the day just to, call you at 2 a.m. in the morning, see how everything's going, 2 a.m. for us, but.
Yeah. So what time periods do you usually have work?
I work 4 to 4 p.m. to 4 a.m.
Wow.
Yeah. So we work a split schedule. So if I work a day this week, I will not work that day next week. Every other weekend, you get a Friday, Saturday, Sunday off.
Okay.
But yeah, 1 week you work 4 days, and 1 week you work 3 days. So you average out to a little bit of overtime every pay period. But that's the deal with 24/7.
Yeah, I respect what you're saying about not quitting whenever it is that Hex blows up and your Staker app is telling you that things are glorious and you'll never have to worry about money again. You still need something to do. and you still need to be grounded. You still need to have, mentorship above and below. So don't, mess up your life structure, what you've built, what you've spent time building, just because of finances being, let loose. But go on vacations, come down to Texas, enjoy
Yeah,
your
I
time.
plan on coming down in January, so I got everything all booked up and
Awesome.
all that jazz. So I'll be down there in January.
Yeah, so January 21st, if anybody's in Texas, come on down to my hometown, Georgetown, Texas. I'll do another one of those events celebrating Marcus coming to town.
Uh, see if I can get Axis to come down with me. He might be able to.
Sweet. I guess that's about it. Thank you so much for doing this week's show and tell. Basically, I've learned a lot about you, and all of this stuff is so interesting. When it is that this isn't our daily scene, we don't see all of these things. We just see the milk carton at the store.
Yeah, that's a lot of people. That's the one unfortunate aspect of the whole nationalized food system is we don't get to see where anything comes from. We just go to the store and pick up a bag of carrots or whatever, or like you said, a milk carton, and that's that. But there's a lot. People don't grasp the concept of how much energy goes into that, not just from the production side, but from the processing side and the transportation side as well. I know that's a big thing with us is the transportation costs. Fuel price doubled, I think, for diesel fuel and all that jazz. So I mean, I think natural gases went up as well.
So tell me, your energy costs that increased, what is that? And what delivery systems do you guys operate?
We have natural gas primarily for our heating. Our heating, the whole factory runs on boilers. So you use hot water to more or less heat all the washes up and all the processes that involve heat. That's all done with a boiler through natural gas and electricity for all the lighting and the motors and whatnot. So I don't know the exact numbers, but our energy usage per month was about $75,000 2 years ago, and currently I believe it's about 110. And our natural gas cost was a little under $100,000. I think it was like 90, 95, and now I believe it's closer to 170,000 a month.
Wow.
Yeah. Well, I mean, we're pulling, I don't know how many megawatts we pull every day, but it's a big facility. There's a lot of moving parts.
So do you know like how the municipality, the local municipality or the local energy grid had to be altered in order to accept your building?
Yes. So we contracted directly through. We're not in the. We use the business. We're in the business district of our municipality. We had to contract through the energy provider to have bigger transformers and to have larger pipelines for natural gas. And we actually ran into trouble last winter with the natural gas was too low of pressure. Like we were pulling too much of it that they didn't have, they couldn't supply us. So we had, I think we have contracted with the energy provider again to have them put a larger line in. The other thing is water. You gotta, if we go through 100,000 gallons of water a day, that we don't use city or municipal water. The municipal water that we do use, we had to have the municipality put in a larger line that ran to our facility, because we actually collapsed the line coming to our facility from more or less vacuum.
Wow. Okay.
Yeah. But that's the, this is not a gigantic plant by any means. There are far bigger ones, but some of our, the numbers sound big to a lot of people, and they are big. I'm not saying they're small, but it's an interesting place, just because you get to see a whole lot of things that I had never seen before. And that's the thing with like membrane technology, that's a really big deal. Like, people don't understand how big that is, but when we run out of water, we're going to have to figure out a place to get it. And well, the ocean's full of it, so we just got to pull the salt off of it.
I agree. And you said it was 3 million square feet of a facility.
Yeah, just under 3 million. Yeah.
Neat.
I don't remember the exact number, but yeah, it's just under 3 million square feet. And it will be probably 3.4 million by the time it's all said and done.
Right. Well, cool, man. Thanks for sharing all this. You want to sign us off?
How did I sign off last time? Well, still waiting for Pulse Chain. Whenever we can get that going, that would be great. Thanks, Richard, for all you've done. And I hope everybody has a great evening and have a happy Halloween.
Happy Halloween!
Hallelujah.